Hi, I'm Darren, and welcome back to Level Up EE Lab. It's finally time on my HF transmitter project to start stuffing this case with all the circuit boards and putting all the controls on, and that'll be the subject for today's episode. Let's check it out. Here's the case for this project, and I'd mentioned in an earlier episode that I originally bought this on Amazon for my simple HF receiver project, but realized it was just too big and ultimately found a much more size appropriate case for that receiver. It's made up of 6 aluminum pieces, 2 extruded channels, and 4 sheet panels. These 2 panels hold the entire assembly together with 6 screws apiece, 3 at the top, 3 at the bottom. I like it. It's a clean look, and because the whole thing can be disassembled, it should be easy to cut the various holes and openings that I'll need for the controls, the connectors, and the display. I'm using these longer pieces here as the front panel and as the back panel for the case. Now, one thing in particular that I don't like on my projects are seeing exposed fastener heads, especially when there's no other styling feature around them. There's not much I can do about these here on the side panel, but I've got an idea about what to do with these here on the front and back panels. I'm also wanting to make the transmitter usable in 4 different orientations, so this could be up, this could be up, and then the 2 other orientations. And I'll just rotate the display text and software to keep it right side up. I'll need mounting feet to keep this metal case from scratching my table, so I came up with this design that has mounting surfaces on all sides and will fit on like this. And they also have another feature built into them. They overlap those mounting screws so you can't see them. Of course, I'm going to need screws to hold these feet on, but I've designed this shape with a recessed pocket for the screw head, so you won't be able to see it hardly at all, and I'll use screws that I've painted black so they'll blend in even more. I think this is a big improvement over the look to hide those screws and make this entire design nice and clean. Alright, so let's take a look now at how I'm planning to stuff the inside with all of the hardware, and for that we need to look at the 3D model that I built. And here it is. I admit I did go hog wild with this effort, but I had my reasons. Mostly because there's a lot of stuff to pack inside this case. Now there is plenty of room, but I really needed to play around with various ideas to find the best locations for everything and to make sure nothing interfered. Now I did just finish explaining how I don't like seeing visible screw heads on the outside of my projects, and all of this stuff will need to be secured with a bunch of screws, so I needed to find a way to hide them all. To do that, I've added this component here that I'm calling a backboard. It's an additional aluminum panel that will have most of the interior parts attached to it, and it in turn will slide right into these channels in the top and bottom extrusions. The backboard is spaced just far enough away from the case side panel to leave space for all the screw heads. So that way there won't be any fasteners visible from the outside. Okay, so let's have a look now at how I've arranged everything inside. Up front and center is the display, and right behind it is the main board, which contains the Arduino and the SI5351 signal generator. Here in the bottom corner are 2 small switching power supplies, one for 28 volts for the RF final amp, and another at 12 volts for the rest of the transmitter circuits. For the rest, let's follow the signal flow, starting in the front corner here with the microphone amplifier, and on top of it we find the balance modulator. Next comes the crystal bandpass filter with its IF amplifiers, and then above the balance modulator I place the second mixer. We then move up to the post-mixer bandpass filter, which should look familiar. It's the same form factor as the bandpass filters that I designed for my simple HF receiver. After that, the signal continues to the RF preamplifier right here, then up to the back panel for the RF final amplifier. Lastly, I put the antenna module here. It contains the low-pass filter and transmit relay, and then out to the antenna connectors. This guy up here in the top corner serves as a 12-volt power distribution node, plus has a simple audio oscillator for the CW side tone. Oh, and I'm showing a divider here. This is an additional RF shield around the higher power RF stages. I'm not sure if I'll need it, but I packaged protected for it just in case I do. Some of the challenges with fitting everything inside this case included keeping the 2 filters and areas easily accessible for band swaps, preserving a somewhat smooth signal path without crisscrossing all over the inside, and keeping amplifier outputs away from amplifier inputs. There's no perfect solution to all of those constraints, but what I came up with here should work just fine. Let's wrap up the virtual tour by looking at the front and back panels. Now, I did go over them already in a prior episode, but I've made some changes since then, and now that I've finalized the design, let's take a fresh look. If you recall from that older episode, I explained an idea I had for using tilt switches to do the display reorientation automatically. However, since then I had to alter the pin usage on the Arduino, and I ran out of pins, so no tilt switches. But no worries, I'll just add a menu-driven option that the user will have to select to do the reorientation manually. And speaking of menus, the big knob here is the main control. It'll adjust the transmission frequency, and pushing it will open up the menu for changing various parameters. Very conventional approach. I'll go through all that in more detail once I create the episode on the software that I'm writing. Below it is the connector for the microphone, which I've chosen to be compatible with a Kenwood mic that I have on hand already. And lastly is a rotary pot for adjusting the mic gain, as well as turning the unit on and off. Looking now at the back panel, most of it is dominated by the heatsink for the final amp. Above it are two RF connectors, an SO239 for connection to an antenna, and a BNC to route to a receiver antenna input. The internal antenna relay switches them appropriately between transmit and receive modes. I'm using a BNC for routing the signal to a receiver for two reasons. It makes sense to visually distinct it from the antenna connector so it's harder to confuse them. Plus, my simple HF receiver that I plan to use with this rig has a BNC on it as well, so I can just use a regular old BNC cable to interconnect them. Next, we have a conventional AC cord socket. I really like using these versus hardwired AC cords. And finally, an 8-pin GX16 connector. I'm using this to route power and signals to and from my HF receiver, as well as breaking out the connection for a CW key. I'll make a custom cable to hook everything up. Yeah, that might have been a little over the top, but all I can say is we all tend to get lost in doing the things we truly enjoy doing in life, and in my case, it's designing things in 3D CAD. I've designed quite a few plastic and metal parts in my career, and I truly enjoy it. Of course, all this attention to 3D detail really isn't necessary to make rock-solid electronic equipment like transmitters and receivers. Case in point is one of my favorite YouTubers, Charlie Morris. Now, he's done quite a few projects over the years where he's built really nice amateur radio receivers and transmitters and transceivers, sometimes on nothing more than just bare copper board, and they seem to work quite well. But I guess that's just me. I don't mind spending the extra time and effort to make my projects look really nice. Things like my spectrum analyzer, the HF receiver that I made last year, even the little facelift on the AV3 that I did recently, and way back when I did a version of Mr. Carlson's Super Probe. I put a little touch of industrial design into it, and I really like the way those turn out. Okay, now on with the build. The first piece to fab is the backboard. I made a scale drawing and printed 2 copies of it. One I'm using as a sacrificial template that I've taped to the backboard, then use a spring-loaded center punch to mark all 27 holes that I'll be drilling in it. It's an age-old method, but it's simple and it works very well. Here it is all drilled and deburred. It's 1.6mm thick 3003 H14 aluminum alloy if you're interested. Now that's definitely not 6061 T6. This stuff is a lot softer and gummier, and it burrs like crazy. It's really more like highly compressed Schlitz beer cans than anything else. But it'll work fine in this application. Next I did a quick test assembly just to make sure all the holes were in the right locations. I'm using number 6 screws and standoffs, and I drilled 5/32 holes in the backboard, which gives the right amount of wiggle room for the screws to align with the circuit boards. Everything checked out fine, so I'll take it all apart and desolder all the temporary wires and the temporary coax cables. Then I'll restart assembly one board at a time, including running all of the wiring that each board needs. But before that, let's look at the front and back panel fab. The front panel needed a large rectangular opening for the display. It's a bit thicker at 1.8mm, but a pair of hand nibblers was still able to make quick work of it. It's a bit tougher material than the backboard, maybe it's made from old Budweiser cans. I covered the panels with masking tape to reduce the chances of me scratching them up during these fab steps. That's an old school trick and it works pretty well. Here's the bezel. It's one of the 3 pieces that I designed and 3D printed to retain the display. You can see the undercuts here. That's where tabs on the 2 retaining bars will fit in and lock everything together. The flange overlaps the rough cut edges of the opening in the panel and makes everything look neat. Again, I'm staying with my principle of avoiding visible fasteners wherever possible, and the bezel does just that. And here's one of the 2 retaining bars. You can see the 2 tabs on it. That's what engages the slots in the bezel. At the ends are 2 captive number 3 nuts that align with the mounting holes in the display. Assembly is easy. I just push the 2 retaining bars against the flange of the bezel, which sticks the tabs into the undercuts and locks everything together. Next comes the display, which attaches with 4 number 3 screws. Now, these screws are on the inside of the case, so you can't see them. Tightening the screws sandwiches the stack together, and the retaining bars cannot slide back out of the undercuts because the shanks of the screws prevent them from moving outward. The only tricky bit is the front panel is not squeezed in the stack when the screws are tightened. So what I did was size the thickness of the tabs and the width of the undercuts to have a tiny bit of interference, which holds the aluminum panel tight enough to keep the stack from sliding around in the hole in the panel. And my idea worked great. The display is held snugly into the panel, the shape of the bezel gives a nice trim out around the edges of the display, and of course, no visible fasteners on the outside. On the back panel, I had no real practical alternatives. Many of the items were going to have visible mounting fasteners, but at least it's the back panel. The power connector needed an oblong hole, and kudos again to the soft aluminum. A file made quick work of it. Heck, a cheese grater probably would have worked just as well. You can see the heatsink attached there in the background. I'll talk about the final amp in a future episode. But right now, I want to rant about modern cheap connectors. This is a new SO239 that I bought at a Hamfest last summer. It looks nice, but it's a complete piece of crap. The center pin is not mechanically locked into the insulator. It can spin around when you're plugging in the mating half. Now that is a disaster waiting to happen because inevitably you're going to twist it, and that will tear off the solder joint to the cable center conductor on the other side. Nice! Now you have an open circuit between your power amp and your antenna. And the icing on the cake is the threads on the shell are malformed. You can't fully tighten down the sleeve on the mating half, which leaves the center floating axially. So worst case, another open circuit, this time between the shell and the ground. So 2 ways to blow up your amp. Fortunately, I still have a few of these older SO239s. They work just fine. They don't have either of these 2 issues. They're just a bit tarnished. I tried removing the tarnish with the aluminum foil and baking soda water technique, which didn't do anything. But I have no problems at all choosing performance over looks here. Alright, I'm about halfway done with the assembly of the transmitter. I thought I'd take a break here to show how I have it laid out and the techniques that I use. And fortunately, with the way this case is constructed, it's making wiring pretty easy because the back panel, I've got the heatsink on it, of course, and it's pretty stable just to sit partially upright by itself. The front panel I can lay down in front of the backboard that I described earlier of what I'm doing here to attach all the circuit boards to, and then I got plenty of access, so that's really good to be able to get in here. And I'm basically building it from the power supply out. I got to, like I said, about half to maybe 2/3 of the boards in place. And I'm trying to be as neat as I can with the wiring. So certainly using the turntable helps a lot with access to be able to get under the boards, and they're just floating in place in some cases or just lightly attached so that I can get the wires cut to length as closely as possible. And then of course trying to bunch them here in the middle. I will either use some loom or some wire ties to neaten this up when I'm done. But for anybody that's done this before, this is certainly a messy operation. I mean, the workbench just looks like a disaster right now because I've got so many tools out that I need to use at some point. And then last thing I'd show is I actually took the time to make a wiring diagram for the transmitter with each of these blue blocks representing an individual board. Green is connectors, and then kind of diagrammed out what needs to connect where. And this is very helpful, especially for power and ground. It's so easy to miss finding where you need to connect something up to power or miss a ground somewhere. So sorry about the tripod bumping around here. Don't have a handy cam mount, but nonetheless, it's going well. And this is actually one of the most therapeutic parts about working on projects that I love, because it's calm, it's relaxing, and it's something that you can take your time with and make it as neat as you want. And certainly having the documentation worked out is a big help to get it done right. Jumping ahead a few days, here's where I am on the assembly. I'm almost done. In fact, the only elements that aren't in the rig right now are the RF preamp and the bandpass filter. And I want to talk about that because a couple
things have developed here. The first is I actually have the circuit boards in transit for the new push-pull design that I have in mind for the RF preamp. Probably going to get those this week, so it's actually not that bad timing. I may drop that in here depending upon how it tests out when I build it up in place of the two N5109, so we'll see. There's a bigger issue, however, with the bandpass filters. Now, I intended to use the ones that I built for my simple HF receiver, and since I built that project, I got my Nano VNA and I tested out these filters, and they're really not that good. They're fine, they work okay for the receiver, but the big issue is most of them have upwards of 10 dB of insertion loss, so I kind of didn't do a very good job of either layout or component selection or design on those. However, I found online a kit of bandpass filters that actually seem like they perform much better and they're appropriate for this type of application. Those are also on order, so I'll be trying those out, and hopefully those will perform better than the ones I came up with. But other than that, I am happy with how this turned out. I had plenty of time to take care with routing all the wiring and get things looking really neat. And I tried to put in strain reliefs everywhere too. You can see that on the back panel for the coax, and especially here on this front panel. This kind of tucks up nicely now when I put everything together, and everything is strain relief, so it doesn't put excessive stress on solder joints. So I'm happy with how that turned out. I did have to cut into the connection for the 28 volt power to the PA because I forgot that I've got to set the bias current on this, and rather than having to desolder and check it and then solder it again, I had some spare Molex connectors in the junk box, so I came up with just put in a splice there, then make this T-shaped piece that I can connect in temporarily and hook up to an ammeter and measure the bias current and move on. I probably would not have spent the money to buy these, but I had these in the junk box, and one of the habits I get into, and I'm sure a lot of you guys too, junk boxes are not intended to be massive hoards for eternity. You got parts in there, use them, find a use for them. So I tried to do that here. And speaking of that, let's talk about wiring really quick. Of course, I've got some brand new 24 gauge wire. I use a lot of this in a project like this, but I also have salvage wire. I got a whole bin full of just wire that, in this case, this is an old computer power supply harness. This was in a box at a Hamfest I went to this past summer that was full of free stuff. No reason to throw this out. I mean, it's probably still plenty long enough for most projects. It's different gauges and adds more colors to the mix. So look for this stuff when you go to Hamfest or Salvage. Sometimes picking up this you'll find a use for, and it'll work out just fine.
It's time to put the rest of the case together, and that begins with attaching the top and bottom channels to the back panel. Now, the screws that hold these parts together are only M3s, and the threads and the channels are not full diameter. So you really have to be careful. These could strip out very easily. It's a weakness of this design. Next comes the trapped side panel, and it slides easily into the grooves on the top and bottom channels. Now you can really see the advantage of my backboard concept. All of those screw heads get hidden away. After that, I can fasten the front panel and the same tricky bit as the back panel. Gotta be careful with those screws. Also, I'm keeping an eye on the harnesses on the other side to make sure nothing is getting pinched. So far so good. All of the screws are threading in by hand, and I just have to be careful not to let the screwdriver cam out and dig a big gouge in the panel. With the front and back panels attached, I took a look at all the internal wires to double check that nothing got pinched, and all is good. So I peeled off the protective masking tape. And it seems to have worked well. None of my handling and fab operations cut through it. Unfortunately, that's where the good vibes ran out. When I tried to install the feet, I discovered a boneheaded mistake I'd made. It seems when I used a foot as a template to mark and drill and tap all the holes, I forgot to account for the thickness of the panel. So they're misaligned by 1.8 millimeters. Yeah, that really sucks. So setting aside that blunder, I moved ahead with closeout. The removable side panel fits snugly into the recesses on the top and bottom channels. Then 6 screws hold it in place. Now these will be exposed. I've got no solution for hiding them. The last bit of bling is the large knob for the encoder. It's the same style knob that I designed for my spectrum analyzer, and it matches the style of the microphone gain control knob. So there you have it, looking sharp. Yeah, that was a stupid mistake I made with getting the alignment for drilling those holes off. But I don't know about you guys. I haven't made very many smart mistakes in my life. All kidding aside, it won't take very long to fix that issue. I will just alter the 3D design for the foot and then print 4 new ones. And I don't know, I'll keep these in the junk box and maybe I'll find a project in the future where I will get them aligned correctly. In parallel with creating today's episode, I've been recording footage for the next 3 episodes, which will be following in rapid succession here. After this one, I will have an episode on the main board that will also show the power distribution board and the integrated side tone generator. So that'll be the next episode. After that one will be all about the RF final amplifier, and I'll show whether it works or doesn't work. No spoilers today. And then after that one will be an episode on the software. And then what should be the final episode in this series will be debug, getting it on the air, and making some contacts. So as always, thanks very much for watching my channel and watching this series. I do hope you're enjoying this material, even when I don't get it right the first time. And until next time, bye for now.